x squared minus 2x minus 3. Nice. And you're setting that equal to 0. Can you tell me what the factored form is, please? So it's 3 times what?
Take out 3, and then it's x minus 3, x plus 1.
X plus 1, and that equals what?
That equals 0.
0. So what does x equal, Chris?
X equals 3 and negative 1.
Okay, so those are x values. So you know that f prime of 3 is what? You just told me. F prime of 3 is equal to what?
0.
0. What's f prime of negative 1 equal to? 0. So what could happen at those x values? What could happen at those x values? You could have a max. You could have a max or a min there. You could. How do you figure out if you have a max or a min at either one of those points? How do you figure out?
Is it possible you could have neither? Or?
Yes, it is, because here's x cubed. What's the derivative at the origin of x cubed? 0. Is that a max or a min? No, it's neither. It's neither. So how do you figure out if it's a max or a min at each of those points?
Enter them into the original equation.
No. That tells you where the points are.
Enter them into the third derivative equation.
Third derivative?
Or
The second derivative tells us about concavity. So before we do that, tell me the y values at those points. What are the two y values? Figure that out. What are the two y values? Those are two x values. Find me the two y values. Find me the two y values.
Negative 27 plus 8. Plus 3.
Yeah.
27 times negative 3.
5 more seconds. This is not a challenge. This should not take you too long. You're just evaluating. You're just evaluating. 1. 13? So what are the 2 points? You have 2 points. You have 3, negative 19, and you have negative 113. So those are two potential, you don't know if they are yet, mins or maxes. They both could be mins, they both could be maxes, you don't know yet. So how do you, can someone clearly with full sentences, so subject, verb, noun, full sentences, how do you figure out if each one is a min or a max? How do you figure out if each one is a min or a max? Tell me, what's the first step? What do you do? You know how to do this, you've done it, take a guess.
Plug the 6x minus 6.
Yeah, f of x is going to be 6x minus 6. So what do you need to plug into that now? What two numbers? What's the first number you need to plug in?
3.
F double prime of 3 is going to be 6 times 3 minus 6. That's what, 12? And what's the second one you're going to need to plug in? So f double prime of negative 1 is 6 times negative 1 minus 6 is negative 12. Well, 12 is greater than 0, so what does that mean? Therefore what? Concave what? Concave what? Up. This is less than 0, so that means it's what? Concave down. Therefore. Those mean therefore? That is a real math thing.
Is that Greek?
I think it's just math notation. I don't know where it first showed up, actually. Maybe from sort of Greek derivation. I don't know. So concave up, what does concave up mean? That means it's a minimum, and concave down means it's a max. So we know that here, this is going to be a max. And what's this going to be? A min. Excellent. Okay, so there's one last type of point we haven't found yet, though. We found where the mins and maxes are. What have we not found yet? We've done the mins and maxes. What else do we need to find now? Points of inflection. Which derivative do we look at for points of inflection? So we take the second derivative, and what do we set it equal to?
0.
So f of x is 6x minus 6, and we set that equal to 0. So if we set that equal to 0, 6x equals 6. So what does x equal? 1. So that's where the second derivative is equal to 0. If we want the point is an x value and a. So where do we need to plug in 1? The original equation. So f of 1 is what? Well, it's going to be what? 1 minus 3 minus 9 plus 8 from the original function right there. So what does that come out to be? Can someone tell me what that is?
1 minus
Negative 2 minus 9 plus 8. So what is that? Negative 11 plus 8. What is that? Negative 3. So 1 negative 3. We think that's a what? Point of inflection. We could verify that. The strict definition of point of inflection is changes concavity at that point. So the second derivative needs to what? Change sign at that point. So what do? You make this sign diagram. You make this sign diagram. So this is f double prime of x. And when x is 0, sorry, what is it? 1, you know that the second derivative is 0, right? Well, here's our second. This right here is our second derivative. What number is to the left of 1? Give me a number to the left of 1. Plug in 0 into that. What's f double prime of 0? Negative 6. So that means that this whole thing has to be negative to the left. What's to the right of 1? 2. What's f double prime of 2? It's going to be 6. So that means that to the right is going to be positive. So it's concave up. Did it change concavity? Yes. So this is indeed what? A what? Point of inflection. Okay, so this is what I'd like you to do. Take this information right here and graph me as accurate a graph as you can with the information that we just figured out. Draw me a picture as accurately as you can with the information we just got. Point. It has to, and then it goes like this. That's a min, right? So what happens in between? Well, my arcs are terrible right there, so I'll do a better job. It's going to look something like this, right? The change in concavity, that's the point of inflection. This is your min, and this is your what? Max. You know that it has to be concave down all the way to the point of inflection, and then it changes to what? Concave up. So this point right here, this max is negative 1, 13. The point of inflection is 1, negative 3. And the min is what? 3, negative 19. That's what I'd be looking for. You need to put your axes. So you see how you need to modify yours? Yours doesn't come down again. Changes from concave up to concave down. You can exaggerate it so I can see it. Sometimes it's a little hard to see, but just remember, it's careful though. Yeah. Careful. You see, you have to bend it up. Careful with the bending. Careful with the bending. Okay. So this is where I gave you a function, and you ended up coming with a decent graph. So now the opposite direction is this right here. The opposite direction is this. The opposite direction is this. Let's take a look at zeros on the first derivative. What's happening here? This is what's this one? That's a max. And what's this one? A min. And then what's happening here? The second derivative changing sign. So what's that? Point of inflection, right? So a negative second derivative, what does that mean for concavity? Down. Concave down. And what does a positive mean? Concave, no, positive second derivative, concave up. What I'd like you to do is try graphing what this looks like. Try graph, again, can your y values be a little different? Yes, so don't go wild with your y values. Just give it a try. Give it a try and tell me. So what can you say? Well, max is happening at x equals negative 3. So go to negative 3. And you know that wherever the graph crosses that, it has to be a what? Wherever the graph crosses x equals negative 3, it's a max. Where's the min happening? Around what? What x value is that? 1. So you know right here what has to be happening? X equals 1 is somewhere on there is a min, right? Where's your point of inflection? Where's that point of inflection look like it's happening? Oh, just round. It looks like it's negative 1, right? So what's happening right here? A point of inflection. So then you can look at the original function. You know it's rising until the maximum, right? You know it's rising until the maximum. So what can you do? You know it's rising until you get to it, right? And then what's happening? The function's rising until it gets to the maximum, and then what's the function doing?
No, it's becoming negative.
If it's rising, then it's what after that? Give me the opposite word of rising. Falling, yeah. It's not necessarily negative. What is the derivative is negative, right? Yeah. So at first it's rising, and then it's what? Falling, right? And it's falling all the way until what? It's going down until it gets all the way to what?
It looked like 0.5.
Well, round it to 1 again. We picked 1.
Okay.
If the function is rising to negative 1 and then it's falling to 1. So you know it's going to go all the way down. But what happens when it crosses that blue? So it's going to go down, right? And then what happens when it gets to here? It changes concavity. It goes to the point of inflection when it gets to negative 1 right here. It has to change concavity, right? So it goes to concave up. Okay, the minimum here. Oh, look. Look at this original function. It's, the function is, what is the function? Oh, where did we change that?
Yeah, that's what I mean.
I know, hold on. I understand what's going on here. So this is the proper derivative, right?
Yeah.
But where does the function need to be?
Below the x-axis.
What did we not label here? What are these? This is where the function is.
X-intercepts.
Oh, we didn't label the x-intercepts. So we should label those. Let's label the x-intercepts. Those are really important, right? What are the x-intercepts, Arvin? Those are those 3 points right there.
Equals -5, x.
-5, 0, and what?
-2, 0.
2, 0, and?
3, 0.
So those are what? Those are called x-intercepts? Are those important?
Yeah.
Yeah. So what do we have here? -5. Where else? -2, and what?
3.
3, right about there. So this thing is rising, and it's, so what is it going to do? It's going to go up, and then what happens?
It starts falling.
Falling, right? And then what happens? It keeps going down, right? And then what does it do? It goes up again. So what's happening? What's happening from here to here? What is that?
Concave up,
No, look at the yellow. Concave down.
down.
Down, and then what does it change to?
Concave up.
What's that point where it changes? What's that called?
Inflection.
It's that point of inflection. There it is. So that's what it looks like. So is it really important to figure, are these zero? Zero is like your favorite number now, right? Yeah. 0 for the first function are the x-intercepts. 0 for the first derivative are going to be maxes or mins. And then 0 for the second derivative will be point of inflection. Yes.
I didn't even notice this until now, but is it at all relevant that it says just f of a says f of 1 equals -3?
Look at that. F of 1 is -3. So it says f of 1 is what? -3. So we could see this curvature right here. What could we do with this curvature?
Move it up.
We could shift it up a little bit, right? F of 1 is, so where, see it crossed right down there? F of 1, we should label that point. So if we clean this up a little bit, we take this. That's a very good, I totally missed that, Noah. Thank you for pointing that out. So if I change this just a little bit right now, where's F of 1 is right about there, right? But we know what happens at, it's a what? It's a min right there, right? So what's this going to do? It's going to go up. Is that a little better? Yeah. So, is that concavity a little off right there? So it should go, what is that concavity? It should be concave down all the way to there, and then it changes. So what is this? It's concave down, and then it changes to what? Concave up. On a test, it might be hard to write that, but just label that as the point of inflection. There you go. What point is that one right there? That's 1 comma what? -3, thank you. And then you have your x-intercepts. Oh, that's cool. Does it give you the max on this? No, you don't know where the max is. You just estimate it. But you know the max x value is -3, but do you have any idea what the y value is? So this x value, that point could be up or down. That point could be up or down. So what should you label first? Yeah, so those are going to happen at -1, 0, and where? 4, 0. So -1, 0, and 4, 0. Kids? So then, let's do the, it tells us also this, right? 2, -5. So that's the point, 2, -5. So let's plot that. Where's that? 2, -5. And you know it's a min.
Yeah, we just used it as a min.
It is a min. Exactly. So if it's a min, and then you know it's concave up. Where's the point of inflection? At, what is that x value right here?
-3.
And where? There's another point. 0, right? So you know that there's a point of inflection somewhere on there. And where else? Negative what? -3. That's a point of what? Point of inflection somewhere on there. So we can do some, let's plug the other, where's the derivative 0 at x equals, -3 right here, right? Okay, so it's neither, so, and the function is positive, so it's falling. So what's happening here? It's falling, and then what happens? It changes concavity, right? And then it keeps going down, and then what does it do? And it goes up. So what's happening there? What are those 2 points, those circled points? What are they? Point of inflection, and what's this point right here? A min, and we know the point of that, it's what, 2, -5?
Yeah.
Nice.
Could we, on a a test, could we like
Nice,
draw
that's
it
really
as,
good.
like, kind of more of a smooth curve and then just circle those points because it's kind of hard
Line
to represent
smooth?
that it's changing in concavity.
Well, what I would do is draw it in pieces. So like I would first draw maybe like this part right here, draw that curve, and then you know also that it's going to be concave up here, right? And then it's concave down to there. You draw it in pieces right there. Draw it in pieces. So actually it was concave up where? I got to do this. It's blue, sorry. This should not be green. What should it be? It should be, if I was doing consistent coloring here, like concave up is this color, right? And then it's concave down, and then it's concave up. How are you feeling about this? 0 is no idea, 5 is you're real strong. What do you think? You can do this? It's okay. I'm still at like 4. I mess up this stuff. If you miss one x value, what happens? It gets all distorted, like you glue it to the wrong point. Yeah, it gets real distorted real quick.